So now we're going to talk about signed numbers. That is, numbers that can be both positive and negative. So there are lots of different ways to represent signed numbers, and we'll talk about some of them later on in this course, but for right now, you just need to know about 2's complement. And the reason for this is because almost all math in computers these days is done using 2's complement. The basic idea behind this is pretty simple. The biggest digit is negative. So if we look at a number, here we have 1000. Before we had, this would have been 8. So we had the 1's place, the 2's place, the 4's place, this would have been 8. Now we say the biggest digit's negative, so now this becomes -1 times 2 to the third, or -8. All the other digits are positive. So if -8 is 1000, if I wanted to make 7, it would be 1001, which would be -8 plus 1, or 7. So for 2's complement, the numbers range from -1 times 2 to the n minus 1, that's if you have this number to 1, to 2 to the n minus 1, which is you get all the rest of them to be 1. So here's an example of some of the numbers. So here's -8, 1000, and here's -7, 1001. This is -8 from the first digit plus 1, which is 7. Or sorry, -7. Now here are the positive numbers. So note the first digit's 0 here the whole time, because there's no negative. It's just positive numbers, and these count up the same way they do in binary. So for the negative numbers, the first digit's always 1, and then you just count up in binary on the other side, and you're adding a larger and larger positive number. So this is -1. It's -8 plus 4 plus 2 plus 1, which is -8 plus 7, or -1. So why do we use 2's complement? Well, it works. So if I want to do addition, if I want to add -5 plus 4, well, here's -5, it's -8 plus 2 plus 1, or -8 plus 3, that's -5, plus 4, which is 4. I get 1, 1, 1, 1, which is -1. I just used the regular addition that we saw for the previous unsigned numbers with 2's complement, and I get the right answer. So we can use the same adders that we had before. There's only one 0 in 2's complement. 0, 0, 0, that's it. There are other number representations where we have multiple zeros. And it's easy to tell if the number is negative. So think about how you do that. We looked at an example last time. So the answer is if the first bit is a 1, then it's negative, because that means you have a negative value in there. Negation, making a number negative, is also pretty easy. So negative a is just the invert of a plus 1. So if I have 2, which is 0, 1, 0, 0, 1, 0, and I want -2, I first invert all of these. So I change the zeros and ones around. So now it's 1, 1, 0, 1, and I add 1, and I get 1, 1, 1, 0. And this is -8 plus 4 plus 2, which is -2. So it's easy to do a negation. That makes it easy to do subtraction. So a minus b is just a plus -b, and you can use this equation up here to work out that just comes out to you do a plus not b with the carry-in set to 1. So now we can build a subtractor with our exact same adder. All we need to do is invert one of the inputs and set the carry-in to 1. So this means that these properties here make 2's complement numbers work really nicely with computers, and that's why we use them. Overflow is a bit more tricky, and we're going to cover that later on, but you can't just look at the carry-out to see if a number overflows in 2's complement. So why did we spend time talking about this? Well, computers use it, and you need to understand it so you know what all these things mean. Remember, we had subtract 2 in our example, or add 1, or is 0, or is less than. So you need to know how the numbers are represented to understand that. And you're going to need this for the first lab. And of course, as I said before, we're going to cover more on this. So this is just a quick introduction to these numbers. Now here's a question. Which of these numbers can be represented by a 4-bit 2's complement number? Well, the answer is -8 and 7. So -8 is 1, 0, 0, 0. That's -8 plus 0. And 7 is 0, 1, 1, 1, which is 1 plus 2 plus 4. If we look at the other numbers, -9 needs 5 bits. So it's 1, 0, 1, 1, 1. This is -16 plus 7. And 8 also needs 5 bits in 2's complement, because we need a 0 and then a 1, 0, 0, 0 if we want that 8 to be positive. Because remember, the first bit in 2's complement is always negative. So here was the table we had before, which shows you how that works.